I will be focusing on practical steps. Now, we heard so much in the past few days. How do we take the step by step towards achieving as we continue? So, the objectives for this presentation, like I said, the first part has been covered mostly. The second part is the practical steps towards integrating AI with modern solving, which I feel should be one of the takeaways from this conference. Okay? So the outline is as it is. Most of the part is to refresh our memories. Our main focus will be on the tools, the skills, and the steps for geomatics and AI integration. What are the tools we need to do all we have heard so far? What are the skills we need? And what are the steps? Okay? So I will show us the steps and show us some platform where we can get started. So when you see me skipping through some slides, please take note. But if you have any question, you can draw my attention so that I can slow down a bit. All right. Just a note, I'll be sharing. I'll be sharing the complete slide I prepared. However, like I said, based on what has been covered, I had to revisit my presentation, but don't worry, you'll get a complete slide. So to start with, we want to quickly look at the evolution between traditional to modern surveying. What are the key changes? The first part is in terms of traditional techniques. For traditional surveying, we use traditional techniques, chain survey, leveling, and all that. For modern surveying, we still use the traditional techniques, but with the addition of technology, more specifically in terms of instrumentation and IT technology. So take note, advancements in surveying do not take away the traditional techniques. Okay, now this is very important, especially for we, the Android surveyors. That most times we believe we just want to use advanced technology. No. The basic and the traditional principles are still very key. Let me give you a practical example. It's based on simple resection and intersection that we do in ground surveying. So your total station has a module called resection, whereby you set up an unknown point. The total station will ask you, how many controls do you have? So if you are concerned about the easting and northing of the unknown point, then you need at least 2 controls. If you're concerned about the northing, easting, and height of the unknown instrument point, then you need 3 controls. Now, once you tell the instrument that you have 3 controls, the instrument will ask you to enter the coordinates, because for there to be controls, that means you have the coordinates. So, the instrument will ask you to enter the coordinates of those control points. You enter the first one, the second, and the third. The instrument will go ahead to ask you to sight those points. So you have your reflector on the first control, you sight the second and the third. And what the instrument does is this. Because the distance has been measured when you sight your reflector, it means the distance is known. The coordinates of those points are known because they are controls. The unknown point you have, the coordinates are the unknown in this case. But remember, from basic mathematics, the distance between 2 points is the distance formula. So square root of changing x, y, z. The d is known already because you have measured it with your teacher station. So using simple simultaneous equation, 3 unknown, 3 equations, you get the coordinates of your unknown instrument point. That is the basic principle used for GNSS. The difference is this. The controls are known and static to some extent. For GNSS, these controls now are evolving. Hence the difference between transmission and reception time. So when you do that for 3 satellites, you have 3 equations to solve for your unknown. But in most cases, you need a 4th satellite because the time, this clock on the satellite and that on the receiver, they have different accuracies. So you have a clock error, which becomes a fourth unknown. In other words, your unknowns now are 3 coordinates and a clock error, 4 unknowns. So you need a minimum of 4 satellites. Now, when you go back to the theories of errors, there's what we call underdetermined equation and overdetermined equation. If I have one unknown, x plus 2 equal to 5, what is x? X plus 2 equal to 5, what is x? X plus 2 equal to 5, what is the value of x? 3. This equation we are used to. Then it means you need 2 equations. But you see, for satellite observations, you need a minimum of 4 satellites. But because of the different satellites available, you can have 10 satellites, 15 satellites. So you have more equations than the number of unknowns. So you bring in this